Hi everyone, welcome back to my channel. Today we'll be doing a part 2 of my Cloud Resume challenge. In part 1, we build out the front end, deploying it to S3 and CloudFront. Also, we added a visitor counter with Lambda and DynamoDB. Now, in this part 2, we are taking this project to an advanced level. Today, we'll be covering 4 important steps: writing Python tests for our Lambda function, creating infrastructure as code using Terraform, moving everything into GitHub source control, building the front end and back end CI/CD pipelines so deployment happens automatically. For this video, I'll do a walkthrough instead of a code along with me. Feel free to ask questions on areas you don't understand. Let's get started. This is my full project layout in the VS Code. Now I have different folders here. The first one here is the GitHub/workflows. This is what have the CI/CD pipeline. This for the front end and this for the back end. I'm going to explain that later. Then I have the IAC, which is the infrastructure as code. This here has the Terraform and the function, which is a Lambda. This is the Lambda function in Python. Then I have the website, which, as we all know, it contains the index.html and the style sheet for the website. Okay, now let's talk about the Lambda function. This is written with Python. Here we import the JSON library, which handles the HTTP. And this bottle 3 is the AWS SDK. DynamoDB returns numbers as decimal. So this function will help you handle that to convert it back to float, which the function will understand, the get function. Then this is the handler, the Lambda. This line prints the event received in your CloudWatch, so it's just there for log purposes. This is where we create the DynamoDB table. So this block of code here tries to get data from the table if it exists. If it exists, increase the counter by 1. If it doesn't exist, you start a new counter. Save it to the view count variable and you return a 200 status. If not, you return a 400, and if there's any exception, you return a 500. Internal server error. That's for the code. Then for the test, same way, we import the JSON and the bottle tree, which is the Amazon SDK. Then this motto is to mock AWS services. So I import it from here, and here we are mocking it. Then we are defining that Lambda function. So the first one tests if you get something else from the Lambda. So it's supposed to return a 200. Yes, it returns a 200 status code if it's successful, and increment the counter. So this one tests if you send an invalid method, it's going to return a 400 not found. If probably use something else that is not there. For instance, here using the post method, when what we set is get, you're going to get a 400 status error. So this one checks if the counter starts at 0 when the item does not exist, and if it starts at 0, you should get a status 200, which happens here. Now let's run this test and make sure it works. So let me pull up my terminal. Then you go to the directory, the Lambda directory. Then you run pytest. So you can see here 3 tests pass. I have one is here, but it's talking about date time being depreciated. I'll fix that later, but you can see from here that our test passes. So that's about the Lambda section. Now let's talk about the Terraform. When it comes to Terraform, we have the 2 main files we need, which is the main.tf and the provider.tf. This one is straightforward. It shows the provider we need, which is the AWS provider, and the version, then the region that we want this to work. Now let's talk about the main.tf file. Let's start with the data. So this data block here zips the Python code. Remember that Amazon Lambda requires you to upload a zipped file. So this code converts that. This your Lambda function here. This Lambda function here, we will zip it up and save it in that same folder. That's what we're going to use to create our Lambda function. So after that, next thing, let's talk about the IAM permissions. We have this first one here, which is the IAM rule for the Lambda function. So we created this custom policy here which will help us write logs to the CloudWatch and read from the Dynamo DB table. And we restricted this to read from only this resume view count table. When it comes to AWS, we follow the least privilege principle. So we don't want you to have access to all the table, but just the my resume view count table. So that's what this policy does. Then we have to attach it here. This resource block attach this policy to the main policy we created here. And after that, the next thing we do is to create the Lambda function. It retrieve that zip file. That's the source here. It retrieve the zip file. Here's the name of the function. This is the row. This row we created here, and this is the handler. Then we chose the runtime, which is Python 3.8, and how many seconds timeout. So here we created the Lambda function. Then another thing I did here was to create the function URL, because for this project I did not use API gateway. I use function URL instead. So this is the resource for the function URL, and here we enabled course. So now to test out our Terraform section of the code, I mentioned that this, you can see from this Lambda now, there is no zip file, right? But once you run Terraform plan, this block of code here, this data is going to create the zip file that will be uploaded to Lambda. So even if you have a zip file there, it's always, if you make a change to it, it's going to re-upload that zip file. Now let's do that. You navigate to the folder, which is IAC. So go to cd IAC. Then we'll run Terraform plan. I already run init. When you run init, then when you create our state files and the .terraform file. So when we run this, you can see here the zip file been created here. Then if we run Terraform apply with auto approve, so at this point now our one file has been changed, which is the zip file. So let's check it out. Let's check it out now. If you go to our Lambda function and let's refresh it, you will see from here last modified 35 seconds ago, which is few seconds ago, right? So this is our function. It's here. It's extracted like it used to. Because normally if you are working on this interface, it's from here you upload, right? And it's a zip file. Look at it, zip file. So but we use Terraform. So Terraform help us put it, save it as a zip, then upload it by itself, right? So this is what we did. Now remember we also created a function URL, and this is it. So if you click on it and open it in a new tab, you can see your views. From this end, it is working. Now let's talk about the CI/CD pipelines. So I've covered the IAC part of the code. Then for the web, more like the back end, we know what is here now. So don't just go into this one. It's just a simple HTML and CSS. Then let's go and talk about the workflows. For the workflows, we're using GitHub Action for the CI/CD. So the front end CI/CD pipeline does something very simple. You automatically upload the website to S3, and it happens whenever we push to main branch. That is the trigger we set here. You can also manually trigger it with this workflow dispatch. So it pulls the repository into the GitHub Action runner. So this Jarvis S3 sync action syncs the website folder directly with the S3 bucket. It deletes the old file and uploads new one. But it doesn't just work on its own. It uses your AWS credentials stored securely in your GitHub secrets, which is what I'm calling here. The source is the website where it saves it to, the region, the bucket name, the access key and access. So this tool helps it access your account. Never hard code anything here because GitHub is not safe. So always use secrets. So every commit instantly updates the live website. No more manual uploading no AWS console clicking to delete and update, all the stuff. So this is what this workflow does. Now let's look at the back end workflow. So this back end pipeline handles testing and deploying the Lambda function and Terraform infrastructure. It triggers when you push to main branch or the manual workflow with this. So it checks the repository here and the directory, which is the IAC directory, that's where the backend code lives. So we'll set up Python by installing the version we specified, which is the 3.8, and every other dependency that we added, which is the PyTest, Moto, and the Boto3 as the AWS SDK. From there, it's going to run our test. This is how we run our test. We're going to run the test, PyTest, IAC, Lambda. That's where our function text lives. Then the next step is going to configure AWS credential. Look at it here, the secret and the ID and the region. Don't worry, when I head to GitHub, I'll show you how to set this up in case you don't want to set up your secret in GitHub Actions. Then after this step, it's going to set up the Terraform. It's going to initialize it with Terraform init here. You're going to run Terraform init. You're going to run Terraform plan, and it's going to run Terraform auto approve. So with this, our backend and infrastructure is deployed automatically. Our IAM, Lambda, DynamoDB, function URL, all are updated through this CI/CD pipeline. So it's fully automated and reliable. So let's commit these changes here so that we can check out the GitHub action. What should we name this now? Changes made to CI/CD files. Commit. Let's go back to GitHub. Then open up our Cloud Resume challenge. You can see the last changes we made is still pending. If it's successful, you'll see a check mark here. If not, you're going to see failure, which is X right here. But before then, let me show you how you can set up your secret. When you open the repo, you go to settings. Then in settings, you go down to secrets and variables. You click on it, you see actions, code spaces, and dependables. So then you go to secrets. Then here you can now add repository secret. Here we added the bucket name, the key, and the secret ID. So to add, you just click here, then you add a new secret. You give it a name, and you put the secret value here. That's it. That's how to create your secret. So now let's go back to actions. When you come to the action tab, you will see the name of the commit you made. For the last commit we did, we use changes made to CI/CD, which is this, and you see the name of the workflow here. This one says upload website to X3. When you click on it, you can see the details here. So the first is set up the job. It built using the Jarvis S3 sync action. Then it ran it. Then it worked. It have already uploaded it, so it worked. All jobs completed. Then if you check the back end action, if you go back and open the back end CI/CD, you'll see that you see all the steps it took. You set up the repo, set up the Python, installed the dependencies, ran the test. Tests were successful, 3 passed. Then it configured our AWS using the credentials we gave to it. It set up our Terraform, ran the initialization of Terraform, was successful. Planning was successful. Apply was successful. No changes made because we didn't make any change to this part of the code. Then it's going to do other stuff, and at the end of the day our job is complete. So this is the CI/CD part of this code. So going back to our Cloud Resume challenge, you can see that we covered all the steps here: the CI/CD back end, CI/CD front end. Then for the blog post, I have a Medium blog post. I created it in 3 parts. There's a part 1, part 2, part 3. In the blog post, you see the code. Also, I'll drop the link to the GitHub repo in case you need it to access the code. Okay, so I like to see what you've created. I love to see your own Cloud Resume challenge live and working. This is our Cloud Resume challenge live and active with our counter. I don't know if I link. Okay, I've not linked it. So here I'll link the documentation here, which is the blog post. So see you in the next challenge or any other project to work on. Bye.